Assalamualaikum and good morning. My name is SYAZWANI and my group members NADIRA and Nurul Amanina would like to present the assignment project about design overcurrent protection of a radial distribution system. Protection scheme is designed to ensure maximum continuity of electrical supply to the load with minimum damage. The design must ensure that the relays will detect undesirable conditions and then trip to disconnect the area affected but remain restrained at all other places. Hence, overcurrent protection scheme is used to detect the current magnitude which exceeds the specified adjustable current magnitude. An electric power distribution system can be classified as radial, parallel feeders, ring main, and interconnected. However, this project will focus more on a radial distribution system. This is some of the characteristic advantages and disadvantages for a radial distribution system. This is the figure for a single line diagram of a typical radial distribution system. Several objectives for this project are to design and develop an overcurrent protection of a radial distribution system, to determine the suitable rating value for overcurrent protection, and to verify the operation of the relays during fault. For problem statement, a task is given to design and develop an overcurrent protection of a radial distribution system, and BEKG software is used as the platform to perform and demonstrate the performance of the proposed overcurrent protection schemes.
Next, in Chapter 4, we will discuss about the result. This is our design of circuit in the BEKG software. Next is the parameters that we use for this circuit. We use voltage generator at 132 kV with frequency of 50 Hz. This is the single line diagram when connected with three-phase fault. So as we can see from the circuit, we connected the time fault logic at the load. These are the graph obtained for fault current in bus 2. The graph show before and after apply the fault current at load 1 for this fault current graph. Next are the graph that obtained for fault current in bus 3. Next is the parameter for current transformers. Poles of the max current fault and maximum load current can be obtained from the calculation. This is the calculation for maximum current fault at bus 2 and bus 3. Next is the calculation for current transformers at relay B for fault at B. First of all, we will calculate the plug setting, which is the nearest one we get is 100%. Next, we will calculate the plug setting multiplier. We get 21.55, and then we will assume the time setting multiplier at 0.1 second, and then we will calculate the operating time at relay B, which is we get 0.22 seconds, and then time at relay B for maximum fault at B we will obtain 0.42 second. 0.2 second we obtain from the circuit breaker time. Next, we will calculate the transformer's current at relay A, fault at bus 2. First of all, we calculate the plug setting as usual, and then we will get 100% as the nearest one. Next, we calculate the plug setting multiplier and obtain 7.183. The next one, we calculate the time at relay A for maximum fault at B, obtain 1.02 second. Next, we calculate the time setting multiplier and get 0.29 second.
So this is simulation part for relay operation. Based on calculation of CP selection for bus 2 and 3, table 4.2 shows the operating time when the fault current is detected. The fault current happens at 0.2 second. Relay B starts to operate after 0.42 second, which the current reaches 0 ampere. But relay A will start to operate after 1.22 second if relay B fails to operate. After 1.22 second, the current fluctuates to 0 ampere, which shows relay A is in open circuit. Relay at bus 2 will act as a backup protection against overcurrent. So this is the fault current happens at 0.2 second until 0.62 second. After 0.62 second, the relay B will start to operate. So the next graph shows the fault current happens at 0.2 seconds. After 1.22 seconds, the relay A will start to operate if relay B fails to operate. As a conclusion, the protection system is important to avoid any issues such as overcurrent. Hence, fault analysis is needed to find the suitable design of overcurrent protection. That's all from us. Thank you for watching.